Hi everyone, pleasure to be here. Thank you for having me. I'm going to cover Swift navigation, our background, our products, and how we've incorporated MBSE into our processes. I have to introduce the company. I'm presuming many of you aren't familiar, so I'll go through that first and then tell you about how we've adopted MBSE and CATIA Magic. This says that we focus on automotive. We actually focus on anything that moves outdoors that needs to know where it is. So lawnmowers, rail, drones, and other applications. However, automotive is really what's driven the need for a much more rigorous systems engineering process. I didn't get the clicker. There's the clicker. So I've covered the agenda. Our purpose, why we want to solve the problems we solve, the products we have made to solve them, the processes which we had to develop to make sure that the things we make are of an adequate standard, the MBSE plan, how we decided we would roll out MBSE, and then what we learned from doing it. So the company, we're a relatively young company based out of San Francisco. The great thing about being really young is that we've got to adopt all of the modern technologies. We don't have any long-lasting roots in traditional methods. So MBSE, cloud technology, machine learning, we've been able to embrace them all. We work predominantly with OEMs and tier ones, so very established companies, often with a long history, deep processes, but also some more modern companies who really drive changing the business structure and development processes of automotive. We have offices throughout the world, so Europe, Asia, and America, and that means a time zone consideration when we're working, and also different languages and cultures between the teams. We're a VC-funded, predominantly VC-funded startup, 200 million raised, and we're on the road with 8 million vehicles. So we're out, people are driving with our technology, some in full self-driving autonomous mode, some who are using us for advanced ADAS or just improving navigation experience. So what is it we're trying to solve? What's the problem we try and solve? What's the purpose? Automotive has a few thrusts. There's full self-driving, there's battery technology. We're really focused on hyper-connected vehicles that want to drive themselves. Precision navigation is what you have in your dashboard or your mobile phone to some extent. But augmented reality is coming into automotive vehicles as well, and you really need a precise representation of your surroundings, and to achieve that you often need precise positioning, precise map and perception systems, and we provide the positioning to that. With V2X, this is vehicle to everything technology. This is cars talking to cars, cars talking to traffic signals, cars talking to anything else, the network, the cloud. And here, position is the same as time. It geotags information and makes it super relevant for any consumer of that information. And lastly, ADAS and autonomy. This is what you may have in your vehicle if you have highway pilots or any functions like that, through to full robotaxi self-driving vehicles. We're headquartered in San Francisco, so I've had the pleasure of being in both a Waymo and a Cruise and experiencing what it's like to simultaneously be in awe of the technology and a little bit terrified. So we've decided to help solve these problems with positioning and regular GNSS. GPS was mentioned in the AI presentation earlier. GNSS is all of the satellite systems. It's just not good enough at 3 meters. It doesn't tell you where you are without any with the accuracy that you need. And so we have developed a system that gets us down to 4 centimeters, which is what you need in order to make the V2X navigation and autonomy use cases really worthwhile. The problem is GNSS is a very difficult science. The satellites are 21,000 kilometers up in space. The transmission signal is about 20 watts. And the receiver technology is often very, very inexpensive. So there's lots of fundamental problems in trying to get down to centimeter accuracy just from the hardware that you use. And then you have The orbits of the satellites are slightly erroneous. The clocks have noise and also drift. Although they're atomic level clocks, they're still error prone. And then the joy of living on this slightly pear-shaped spinning Earth of ours with its atmosphere, that also causes problems for radio signals. So the ionosphere and troposphere also cause errors depending on weather conditions for tropo, but solar conditions. The aurora borealis that maybe some of you saw recently causes problems in the ionosphere that our technology has to estimate and deal with. And then lastly, as I'm sure you've all experienced on your mobile phone, you can sometimes get local effects if you're near a large building or another reflective surface. So our solutions have to deal with all of these difficulties and still get down to centimeter accuracy. So the products we've developed in order to achieve this goal of 4 centimeters despite all of these errors. We've developed a cloud-based correction system that estimates all of the global and regional errors, and we've developed some software that will go into your vehicle or your lawnmower, which takes into account the position calculation and the local effects, so these local reflectors or multipath that you may have. So they're the 2 differentiated product offerings that we have. I'll talk a little bit more about this. The cloud correction service sounds like just a piece of software running in the cloud. It's actually based on these reference stations that are deployed globally, so continental scale, but we have North America, Europe, and Asia as coverage areas. They observe the satellite signals. That data is sent up to the cloud. The cloud calculates the ionosphere, troposphere, orbit, clock, etc. errors, sends it down to the vehicle, where the vehicle forms the position. Skylark is the cloud service, and Starlink is the software in the vehicle. And they're the 2 products that we have developed. And from a systems engineering perspective, for me at least, this is a great systems engineering problem. There are constraints with governmental agencies who control the satellites. There's cloud technology, there's machine learning, there's physics, physical modeling of the environment. There's relativistic effects in the satellites you have to cater for. And there's a cost-sensitive embedded engineering problem with complex algorithms in a vehicle. So if you're a systems engineer, the work we do here is very interesting. Not a lot of mechanical, some electronic, but very much algorithmic and systems engineering focused. So I said we had a global solution. Systems engineering often looks at the technology, but using constellations from different global governments or country governments across the globe provides its own legal, geopolitical constraints to our solution that we have to cater for. And then having coverage in North America, Asia, Australia, and the Middle East, that means our service needs to be maintained, our stations need to be installed and monitored in all of these different cultures. So local laws, local culture, local teams all have to be integrated into Swift as a whole, which provides the softer, non-functional requirements that we have to care about in our systems engineering as well. So the process, they're the products, that's the problem we're trying to solve. The process that we have used in order to solve them. So automotive has driven our process development, and there's a number of standards. I've just listed them here, but they cover everything from quality through functional safety, through cybersecurity. And because we're a service, we also have to have information security, data privacy. So all of these standards are relevant to our company. And we started our journey about 2 years ago, but these were the standards we had to target in order to access this very highly regulated market of automotive. The standards expect, as we've seen and will continue to see today, the V diagram, very waterfall, very program-centric. You decide what you're building, you go away and build it. Case closed. You may have some maintenance and through-life expectations, but then you start a new program, start a new product. We don't work like that. We're a service. we can expect software-defined vehicles and connected vehicles to want firmware over-the-air updates, and we need to continually iterate and improve our offerings. So we follow a DevOps model where we decide what we're building, we go and build it, we put it in front of customers, they test it, they experience it, they give feedback, and then we improve it and we update it. And so managing quality through that process of continuous integration, continuous development is somewhat different to the classic V-model expectations of we've passed validation, we can wash our hands and move on to the next program. So we needed to combine this, and it's very much in our DNA as a Silicon Valley company to move very quickly, listen to customers and react. But we had to follow the standards, which were very V-centric. So we decided that we would roll out MBSE, and we had a number of criteria we were trying to fill. We wanted to be standards compliant. We wanted to make sure that the audit bodies would come to us and say, yes, you definitely have met the goals of the standards. We wanted to be compatible with our current working practices, so compatible with DevOps. We didn't want to give up on speed. We wanted to move very, very quickly, and we wanted the algorithms, code, hardware, electronics to not be hindered by having to have a rigorous process behind it. We weren't willing to compromise that. We also wanted a single source of truth. It's very easy to have a proliferation of different documents in different formats, in different tools. We wanted a single source of truth, a one ring to bind them all type concept for our data management. I mentioned that we're a very diverse company in terms of culture, both from the teams and where they're located, but also our customer base. And we wanted a simple way to communicate to all of those customers and all of those teams without interpretation. One person thinking that blue is green or green is blue or whatever slight subtleties can be, misconceptions that can happen when you use words instead of a clear picture. And we wanted it to be efficient. We're a small company, 150 people. We don't really have the bandwidth to take on processes that may have been designed in the 1990s by automotive giants who have the team in order to wade through the process mire that they have in front of them. We have to move quickly. And so we didn't want to compromise speed, so the solution had to be very, very efficient. So we decided to choose CATIA Magic as our tool. MBSE as the concept and CATIA tool as the implementation of that concept. We've used CATIA Magic for requirements, architecture, traceability through to the code itself and then back up into validation and testing. No other tools. We put everything into databases and diagrams in CATIA Magic. So what we had planned, as you can see, we considered the tools and how we would roll those out. We considered the team and how we would influence the team. And we would consider the training, how we would first build the team and then grow that team's capability through the other engineers. And as you can see, this was the plan. And the big gap to the left of the plan may give you an indication of what actually happened. So we went through an evaluation phase. We got some licenses. We started to test it as far as the tool's concerned. We hired to the team. Unfortunately, we made some very good hires, which helped very, very much. And then training, we've been pushing on the job training. But then we had 1 year of pushing through. And this pushing through was both education, teaching people about the concept and how to use it. But there were also purchasing and financing and cultural changes that we had to go through. But we just had to keep on pushing through for that year. And now into 2024, we're still in beta, but we are now using it as a central tool. We have a plan to recruit into the team and to train other teams, and we're still working with a key group of engineers. One of the questions that came up is how do you manage people? How do you get people involved? At the time, we said we would make MBSE viral, but with COVID, we decided that was probably not the right term. So we talked about seeding teams. We would seed teams with individuals who are system thinkers, and then they would grow that skill into the team. And that's still the strategy. You pick someone who is a systems thinker, they realize the benefits themselves, and then they enlighten the rest of the team. So, where did this plan take us? So currently, we are automotive SPICE level 3 compliant. That's a quality metric. We are 27001, 20,000 and 26262 compliant for our cloud service. And we are compliant, although not yet audited, for 21434 cybersecurity and 21448, which is safety of the intended function, safety through different environments and different conditions. We don't have any references to this, but our customers have said for us to complete this in 2 years is unheard of. It's for the team size that we have, getting all of these standards from a starting point of good practice, solid quality, but no standards compliance defined. This is somewhat unheard of. So we've put everything through the CATIA Magic tooling and then achieved these recent qualifications. And for us, the big news is it's the first real-time cloud-based, functionally safe and certified service. So we work very closely with Amazon Web Services. With them, we've made a functionally safe, connected service for automotive. And if it's safe for automotive, you can read across to rail, you can read across to avionics, you can read across to farm equipment, wherever else we're working. So we're pretty pleased about that. It's taken a lot of blood, sweat, and tears. But I'll tell you more about the learnings, not just the blood, sweat, and tears. Education, justification, and perspiration. This means you've got to teach people, you've got to give them reasons why it's better, you've got to justify it, and then you've got to keep on going, keep on going. MBSE is new for a lot of people. Systems engineering is old. I graduated with a systems engineering degree in 2003, so systems engineering is an old practice. MBSE, people have been drawing diagrams forever, but MBSE as a complete concept is relatively new for a lot of people who haven't gone through that systems thinking process. So they don't necessarily see the benefits immediately. You've got to seed teams, you've got to grow the insight, you've got to make people understand why it's good for them. And it requires investment, both time, both energy, both finance. And so you need to be prepared to make that investment. It needs strong champions, and that's up and down throughout the company. I was fortunate enough to have a boss who said, as a startup, we need to be taking risks, not just in the products that we make, but in the processes we develop in order to build those products. It's really in the DNA of a startup scale-up to challenge the status quo and say, we can do things better, we can do things faster. So it's very important to have champions who give you the space, who back your corner to allow you to do that. And you've got to have engaged teams. And we were fortunate at Swift to have very capable engineers who were driving the adoption and driving the use of the tool as well. So it is all about the culture, it is all about the people, but if you get the right ones in at the start and give them space, they can achieve a lot. Keep on pushing. This comes back to bringing people with you, show the advantages, get people on board, and then let them be the advocates into their teams and into the wider group. And now we're realizing the benefit. One of the things about systems engineering is once you've done it once, when a customer comes along and no customer says, that's great, I'll have exactly that thing that you've already built. Please give me the thing that you have made in scale. They always come and say, I love that thing you've made, but can you just change these 10, 100,000 requirements for me, just to make it specific for me? That's where we're going at the moment now. Further customers coming in, buying the same thing, and we're just slightly tweaking it rather than making it from scratch. So conclusions. We have taken CATIA Magic as the core of our engineering processes, at least the systems engineering processes, and it is possible to develop a complex product using this tool and achieve standards compliance. You can make safe and secure, quick and compliant modern and meticulous processes using this tool and achieve high-quality products with it. And the final summary, it's a tough climb. It's not always sunshine. Sometimes it rains on the way up the mountain, but the view from the top is well worth it. And we're at the stage now that we are benefiting from all that hard work we've put in. And that concludes my presentation.